Again, it's just an introduction of one way that you can do a proof. And so this section is about postulates. Anybody ever heard of the word postulate?
Did you say it once?
Okay, maybe.
Maybe.
Bondo, what do you got? Oh, you heard it before, okay. This is probably on your vocabulary sheet too, okay? So this is also, another word for this is an axiom. So if you ever heard of axiom, then you're thinking of a
We missed a
postulate.
couple.
Go back and fill it in. So, what this is simply a statement. So somebody could say one of these that's accepted as true. And there really doesn't have to be proof. So in I guess a broad example of this would be things that we would just know in a sense. Kind of common logic again. So turn to page 127 if you have your book. On page 127, they're showing you postulates. And so this is one way that they'll show you. So if you honestly wanted to copy all these down, you can, but I don't think you need to because it is in the book. You just have to know that they exist. So I'm not one of those that gets hyper active into this, meaning that you have to know exactly that 2.1 is blah, blah, blah. Okay? You just have to know that postulate 2.1 exists and that you can use that as a reason why in your proof. So that's what postulates are. One of the things that you can use in a reason why in a proof. Okay? So if you notice here, something on 2.1. Now why is it called 2.1? Because we're in chapter 2, and it's the first one in chapter 2. That's why it's called postulate 2-1. Again, when you're doing a proof, if you can remember these by number, you can write down postulate 2-1. If you cannot, then you would write, what's it say? Through any 2 points, there is exactly one line. And we knew about that, right? We talked about lines before. And if we were going to draw a line, one of the ways that we drew it was putting 2 dots and connecting them. So that's true every single time, right? There's no argument about that. Nobody has to prove that. That's why it's called a postulate. So if you go through the rest of them, somebody read 2:2 out loud.
Through any 3 non-collinear points, they're exactly one.
Okay, so any 3 points, right? That's how we can make a plane. And again, that's something we talked about way back in chapter 1. All right, so these are just statements that we know of as being true, and we really don't have to prove them. Okay? So you can read through the rest of them. And it'll show you exactly what you can use. So again, you can use any one of these to explain your reasoning while you're looking at a statement. All right? Does that make sense what a postulate is? Everybody okay with that? Again, if you want to write all these out, you can, but you don't need to. All right? Just put page 127 in your notes or something. All right. So, from there, we start talking about a proof. What's a proof? We'll come back and look at more examples of this when we get to the end. So we're going to talk about a proof. This is simply a logical argument. And in my argument, you need to come up with things that prove it, right? So logical argument using deductive reasoning. So remember when you said, well, why do I have to learn yesterday's stuff? Well, this is the reason why. We're going to use our thought processes from yesterday So we're going to use this reasoning to go from a hypothesis to the conclusion. The conclusion is what you want to prove. So here's the funny thing about these. We're not going to do proofs that are the really long ones. I mean, there's a couple of them in this book that are like 25 steps. Okay? Ours will average like 3 or 4 steps. So we're going to be nice and simple. But what you got to realize is in any one of these proofs, in the book, on the quiz, on the test, we'll give you some of the answers. You just got to use what is given and then construct the rest of your proof. Okay? So one way that I could do this, going from my hypothesis to my conclusion, I want steps. I could use postulates to get from point A to point Z. Okay? Another thing that I could use are things called theorems. This is probably one that, or this is probably on your sheet too, isn't it, Lauren?
Yes.
Okay. So what's a theorem? Anybody ever heard of this? This is simply a statement or a conjecture. What was a conjecture again?
An educated guess.
Yeah, an educated guess, right? That has been proven. So the reason that we can use proof or theorems in a proof is because there's some weird guy or lady in the bottom of some big building in their own little cubicle doing math by themselves and making these things up or proving this through algebra or calculus or something. Okay? Sounds like a fun gig, right? Yeah. So it's that guy that's really, really smart but can't really explain anything. Okay? He's doing math by himself. So, does that sound like a fun job to have? So, these again can be reasons in a proof. So, just like our postulates were given to us, right? Postulate 2-1, 2-2, 2-3, 2-4 on page 127. Our theorems are going to be given that same way. Okay? So the theorem would be 2-1. So you could have a 2-1 as a postulate and a 2-1 as a theorem, but one is basically just kind of a rule. The other one somebody's actually proven through math. Make sense? You're going to use them the same way to justify the things that you say in your proof. Okay? So, how do I write a proof? Process of writing a proof. Number 1. Ladies and gentlemen, if you don't get this part right, I'm going to throw my marker at you. Okay? Write down the given. How do you know it's the given? They will literally say, this is the given. Write that down. That's for sure. You cannot argue that. Remember back at the beginning when I said some of the pictures aren't going to look that way? Maybe they would tell you that it's an acute angle, but it actually looks like it's an obtuse angle. If they tell you it's an acute angle in the given, it's acute. They just drew it wrong. Okay? So, write down the given. That's your first step. Every single time you should always get that point right. Again, if you don't get that point right, I'm throwing my marker at you the next day. And I will. Trust me. Okay, so with every single time that you write a statement in a proof, you need a reason why. Why can I say, or why can I list the given as the first step? Every single time, my reason why is simply, it's given to me. Okay, so when I ask you to write a proof, you're going to write a statement and a reason why. Every single time. This is half a point, this is half a point. So if it's 5 points, you get a half a point for the reason why and a half a point for, the reason why for the statement and a half a point for the reason why. So if it's worth 5, you have 5 halves. Make sense? The first one is given to you. Why is it? Because it's given. Okay? The second thing. Now you might not do this in this particular order, but you are going to use the proof. So every single proof is going to give you a given, and they're going to give you a proof at the very beginning. The given is your first step, and the reason why is it's given. The prove is your answer. That's what you're trying to prove through your process. But it is the answer why. Now here's the thing. The first one you can always say given. The last one, this is really your last step. But you cannot say prove for your last step. You have to come up with a reason why. So you have to use a theorem or a postulate or a definition. So that's kind of the confusing part. You can use given for the first step, but you have to come up with a reason why for the last step. Make sense? Step 3. You're going to find deductive reasoning. So again, that's what we did yesterday, right? To go from the given to the proof. So we would have blah, 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 given. This would be my proof statement with a reason why, and then there's going to be steps in between. Okay, so if I tell you that it's a 5-step proof, the first one's always given to you, you would have to find 3 reasons to go from this first step to this bottom step, and then find a reason why for every one of them. So I will tell you how many steps there are every single time. And to me, that makes it a lot easier. Now, some of you, you'll find ways to do it a different way, and that's totally okay. So some of you, there might be 5, you might do it in 6. You're probably not going to find a way that's smaller than what we tell you, but you might find a way that's bigger. Okay? But we're going to find all of these deductive arguments. Here's the biggest thing with this one. Big star for number 3. Say the obvious. So what are obvious things that we've talked about already? When there's a box, I always know what. When there's a little red box in the corner, what do I know? There's 90 degrees, right? That's an obvious statement. So you don't think you have to say that statement necessarily. You still have to say it. You got to think that you're talking to, I know this isn't nice, but the dumbest person ever made according to math. So you're explaining something to that person. So you got to say the most obvious statements. All right? So 3 and 4 are kind of the same. So 3 is finding those reasons why. 4 is say the reason. Sorry, so 3 was basically coming up with the statement. Number 4 is saying the reason why. Why can I say that? When I do this, I can use postulates. I can use theorems. I can use definitions. What are definitions? Exactly what it sounds like. In the back of your book, you probably don't know, there's a glossary. So you could go back into the glossary and look it up. I can use properties. And this is where we'll actually start, I think, tomorrow already, using algebraic properties. What's an algebraic property? Just simply saying x plus 2 is equal to something. So using plus or minus, addition, subtraction, multiplication. Okay? So these are going to be over here. So number 3 would be the statement. Number 4 would be the reason why. Okay? And that's one of these. So I would say angle R is 90 degrees. Again, I know that because the box is in there. My reason why is definition of a right angle. And that's all I would say. Okay? Step 5. Basically, find a reason for the proof. So we kind of talked about this already. Number 2 is going to be the proof statement, which is always going to be my last step. This is coming up with one of these postulates, theorems, definitions to actually prove that statement. Okay? So, the first way of doing this, and again, I don't know why they do this, but the first way that you can write a proof is through a paragraph. How many people like to write paragraphs? Probably not, okay? So we'll learn a 2-column proof, I believe already tomorrow. But they want you to kind of think about this paragraph proof today. So this is basically writing a paragraph and explaining a situation. When you write a paragraph, you would say a statement, and then you just come up with a reason why that I can say that statement. And then you go from basically the beginning to the end, and you fill in all the blanks. You can use this kind, if you like this kind, you can use this kind of proof the rest of the year, if you want. I just don't care for it, okay? Basically, when you're talking about paragraph proofs, though, one of the things is you might want to do is work backwards. So you might want to go to this proof statement and start there and say, well, why do I know that that happens? And maybe I work backwards. So if you get stuck at where they started you, maybe you go to the end and work backwards. And you can do this in a regular one too, when we get to the 2 columns. Okay? Just a different way of thinking. And again, I know, you're all mad about it.
What did I do? Nothing. I've been just sitting
Because you don't know why you gotta do this.
I'm just sitting here listening.
Alright, so we'll come back to that example up there in a second also. But we want to introduce our first theorem. Here's the other thing. When we start doing these a little bit more consistently throughout the next few chapters, whatever is introduced at the beginning of the day, so like the main topic, is probably going to be the main theorem or whatever that you use in your proofs for that day. Okay? Most of the time I will give you 2, maybe 3 at the most per day. One will be the odd problem, one will be an even problem. So obviously the odd problem, you can do what? Go to the back of the book and use it for help, right? Do not just flip back there and do what Bondo just said and copy it straight down out of the back of the book. The back of the book's there to help you learn how to do that process, right? So you would do the odd one first, try to learn the process, and then take that to the even one. Make sense? Okay, so we are going to talk about our first theorem, which is the midpoint theorem. If you think about this right now, think about the first word. What does midpoint say, or mean? The middle, right? So this is theorem, again, 2-1. Why is it 2-1? Because it's the first theorem in chapter 2. Okay? So, we'll do this through chapter 7 or 8. So that's how many theorems you have. All right? So, again, you do not have to remember that it's 2-1. You just have to remember that there is a midpoint theorem. And if you want to call it the midpoint theorem, that's totally fine. Okay, so this says if M is the midpoint of AB. Can I put the little arrows on this one? Of AB? Why?
It stops.
Yeah, this stops, and if it's a midpoint, there's no way it could be a midpoint of a line, because lines go on into infinity in both directions, okay? So, here's the other thing that we didn't really talk about, so I apologize. If you go back to number 1, it says write down the given. As you're writing down the given, I would always try to draw a picture. Draw a picture, draw some kind of figure that is explaining what is given to you. Sometimes they will do this. Sometimes I don't like this book because they do too much for you. I would rather you actually draw the figure, and they'll say that things are congruent to each other, so you would put the little slashes on them, you know, the little red slashes. But sometimes the book does that for you. I'd rather you just do that, but they don't do that for you. So try to draw a picture or some kind of figure as you're doing this. So could you draw this picture right here? What would you draw? Right? Everybody agree? And where does M go? Right dab in the middle, right? How can I show everybody that that's right dab in the middle? With those little slashes on them, right? So, if M is the midpoint of AB, what's true? What's true in this? Awesome. AM is what? Equal or congruent to what? MB. Awesome. That's it. All right? So, if then statement basically. If M is the midpoint, then I get congruent segments. Again, why are they congruent? Because we're just showing you that there are. They would be equal if they did what? Why can I take this little squiggly off and make it equals over here? If they use numbers. So if they said 6 here and 6 here, which we know that's true, right? Or we don't know what the numbers are, but 6 and 6, then we can put this as equals. And then we would put AM without the slash over top is equal to MB without the slash. Okay? So that's my midpoint theorem. All right, so questions here. I know a lot of information. Okay? Now we're going to look at some examples. So here's my first problem. And if you look at this, I think this was one in the book too, if you want to look at it in the book. Or at least some kind of resemblance of the one in the book. So it says, explain how the picture illustrates that the statement is true, then state the postulate. So open back to page 127, or look on somebody else's book on page 127. And it says points F and G lie in plane Q. Can you see where that is? Can you see where F and G are? I know this one's kind of hard to see. But F and G would be right here and right here. Okay? So plane Q to me is this side of the building. Kind of the shadowed side of that building. So points F and G lie in Q and on line M. See my little M up here? So this is line M. Does line M lie entirely on plane Q? Where does it lie? Say it one more time. So look at your postulates again. If you have 2 points that are on a line, is it in a plane? So go to postulate 2.5. Read 2.5 to yourself. If 2 points lie in a plane, the entire line lies on that plane. So that would be the reason that we would use. So because these 2 points are on that plane, then that whole line is on that plane. Now, Bondo's probably thinking, well, this line is actually in plane P too, right? You were thinking what? Right, it's on the line, but this line would be like the edge of those 2 building faces. So they're actually in both planes. But because it is in this plane, these 2 points are, then that whole line is in there. Because 2 points make a line, right? Okay, let's try again. Do points A and C determine a line? Ms. Grease, what do you say? You say yes, because what? What postulate says I only need 2 points to make a line? 2, 3?
Yeah.
Okay, what do you think? Points A and C, they said 2, 1. What did your 2, 3 say?
A line contains at least 2 points.
Okay, I would live with that. So again, there might be more than one postulate that works. So they said 2, 1, which says through any 2 points there is exactly one line. Kind of says the same thing, just in a different way. So 2, 3, I would accept it. Oh, sorry, I forgot. I didn't let you guess. Plane P contains points E, B, and G. What can we come to the conclusion? Well, a plane contains at least 3 non-collinear points. So remember, one of those postulates says a plane is named by any 3 points. Right? So that's what we would have used in that one. They give you line AB and line BC intersect at point B. Everybody see where that is? Right here? Okay? What can we say about that? A, through any 2 points there is exactly one line. Well, yeah, we could say that, but that's not necessarily what they're saying. A line contains at least 2 points. If 2 lines intersect, then their intersection is exactly 1 point. Yeah, what postulate was that? 6? Perfect. So then you would say postulate 2-6. And that's the reason why I can say that. Determine whether these are always, sometimes, or never true. So again, you got to think about these and maybe draw a picture in your head or on your piece of paper. If plane T contains EF and EF contains point G, does plane T contain point G? Is that always true, sometimes true, or never true? So again, this one is where you might be better off if you draw a picture. Remember, a plane's just some kind of box. Okay? It says, so this is T right here for us. It contains EF. That's my E. Okay? And EF contains G. So, does plane T contain point G? Always, sometimes, or never? Always. Anybody disagree? Everybody see why we came up with that? So this is always because, again, the reason why would be postulate 2-5. What does 2.5 say?
2 points lie in a plane, and the entire line containing those points lie in that plane.
Okay, so does that make sense, what we just read there? If 2 lines lie in a plane, then anything on that point or that line lines in that plane. Again, determine whether this is always, sometimes, or never. GH contains 3 non-collinear points. Well, what does this symbol above GH mean? It's a line. So if we say GH contains 3 non-collinear points, does that make sense? Can that ever happen? No. Never. Non-collinear points do not lie on the same line. Right? Perfect. Plane A and plane B intersect in exactly one point. Can you take a piece of paper and intersect another piece of paper through it and it only touch at one point? Can it ever happen? Sometimes. Really?
No.
How is your sometimes going to work?
I don't know, I just guessed.
Okay, I can live with that. So this is never, because again, one of those theorems says it. I think it's the postulate, way at the bottom. 2-7. What does it say?
If two planes intersect, then their intersection
Is
is a line.
a line, not a point. Okay? This one says exactly one point. So again, it could be that minuscule of a reading of it. And again, this is where it gets a little complicated because you got to remember all of these things. Now again, you don't have to necessarily remember that it's 2-7, but you have to remember that 2-7 says that if I take two pieces of paper and cross them, they can never cross at just one point. That's what that's saying. Always, sometimes, or never. Point N lies in plane X, and point R lies in plane Z. You can draw only one line that contains both points and an R. So that's saying this. Here's plane X. Here's plane Z. One has a dot, one has a dot. Can I draw more than one line between those two dots? I can. To connect this dot on this one and this dot on this one? What? So what do you think? Always true? Sometimes true or never? Only one line. Con's still confused. How about this? That's a point. That's a point. If I wanted to connect those 2 points with a line, can I draw more than one line that would go and connect those 2 points? I can? Show me how.
I just said, yeah, I don't.
We'll start on that one tomorrow. It'll be on the canvas.